doors are great. Don't let anybody take the difference.
All right.
Write that down on the board. Your doors are great.
So
I'm going to write it down.
I have a 3 here, right? 4 here, a 2 here, a 4 here, a 2 here, a 5 here. There's really a 1 there, it's hidden. And there's a 2 here. We found the derivative. So mean. We found the derivative using the power rule, right? So we take the power times the coefficient, right? We get 7 times 3 is 21. Take 1 away from 7, we get 6. And we continue it through. 6 times 4 is 24, that makes 5. 5 times 2 is 10, that makes 4. 4 times 4 is 16, and 1 from 4 is 3, and so forth, all the way down. And we just keep taking another derivative, and another derivative, and another derivative, and another derivative, and another derivative, until we get to 0. And now we want to explain what a derivative is. Right? Okay? So we need some rules. We need rules. And the biggest rule is, we need to know what kind of polynomials we're dealing with. So, from here down to here, we call these polynomials. Right? Actually, from here up to here, these are all polynomials. Right? Now, this is a trinomial. Right? Wait. Oops. My bad. This is a trinomial. No, actually a quartic is only the degree of the polynomial. I want to explain that, yeah. I was incorrect when I said that before. This is a binomial. And these two are technically both monomials. And this is still a monomial. Why? Because it's only got one thing. It's still x to the 0, and x to the 0 is 1, and 1 times 0 is still 0. It didn't change anything. So there's still an x there. It's just invisible. You can't see it. Just like all my friends. So, that was a good one, right? Alright, so then...
That was really sad. We're all in trouble.
True story, though. True story. Okay, so this is what we call...
I told you your doors were good. What words do you want to read?
I know. This is called a quadratic trinomial, right? Okay. This one is called a linear
How do we know it's linear?
binomial, because the exponent is a 1. When your exponent is a 1, you have a linear. When the exponent is a 2, it's quadratic.
I caught that part.
So it's 3 cubic.
When your exponent is a 0, you have a... We like to call it a 0 nomial. It's actually just called a constant.
So would 3 be cubic?
Yeah, that's a good guess.
So a 3 is a cubic. Good. So this one would be a cubic polynomial.
So you're just taking the highest.
And this one would be a quartic.
Wow.
Quintic.
You lied to me my whole life.
Sorry, I knew it.
No.
Oh. So this one would be a quartic, this one would be a quintic, okay? And so forth and so on, okay? What is it? Quintuplets? Xtuplets?
Sextuplets.
Sextuplets. I wonder if it's a sextic.
That's what I was gonna
I'd
say.
have to
Sex
look that
nomial.
up.
It's a sex nomial.
It's a sextic-nomial.
This better not go on YouTube.
I know.
It's going on
Not
YouTube.
a fight.
It's going on nomial. It's going on YouTube. Alright, so then,
It's a sex nomial.
so
You guys are
then,
gonna get fired.
That's my
I know.
favorite.
Just promoting
Now,
things.
we also got to get back to understanding how many humps there are in a sextic-nomial. Right?
Five.
Or in this case, a septic nomial. What's a sept? Sept is,
It's bad when people
that's
do
French for
septic.
seven. But, I don't know what it is. But it's a 7th degree polynomial.
It's a lucky.
Okay.
lucky septic.
And a 7th degree polynomial has how many possible humps?
6.
Yes. So one less than the degree. Always one less than the degree, right? Now, we know that the last hump, we know that the last hump is smiling. Why is that hump frowning?
Because you messed it up.
I did. So, we know that the last hump is smiling because
It's positive.
it's positive. The first coefficient is positive. Duh. So we got 1, 2, 3, 4, 5, 6. Right? So 6 total possible humps. So it looks something like this. Probably not exact. Some of these are probably bigger than others. Like life. So the next one,
What the shit?
right? This next one, it will have, since this is a derivative of this, right? We actually derive derivatives through the instantaneous change in the function. Believe it or not. And the instantaneous change in the function is developed upon the slope of the function. Okay? And so if I were to find the slope at exactly this point, and exactly this point, and 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 then graph them, I would have a very accurate derivative. What we're going to do is something a little bit less accurate. We're just going to be like, hey, what is this slope? Positive or negative?
It's positive.
Positive. So we're going to start that right here. And what is this slope right here?
It's not.
It's 0, right?
Yeah.
So that would come down to here. Right? See where it would be 0? This is positive, this is 0. And then what's the slope right here?
Negative.
Negative. Right? And then what's the slope right here?
0.
Okay. And right here?
Positive.
And right here?
0.
Again.
And right here?
It's just a zigzag.
And right here?
0.
And right here?
Positive.
And right here?
0.
And right here?
Negative.
And right here?
0.
And right here?
Positive.
Wow.
That's it.
And then how many humps does this one have?
5.
Yeah. Because always has a possible hump of 1 less than the degree of the polynomial. And then if I were to do that again, right? I could find this one. And then, do you notice how it's still smiling? Still smiling. Amazing. Why is it smiling? It's a positive coefficient, right? Alright, so now we do it again, and this is negative, right? Oh, I guess I'll use green. Negative, 0, positive, 0, negative, 0, positive,
Just put 4 humps on it.
0, negative, 0, positive. And then you connect your dots. Still smiling. 1, 2, 3, 4. And it has 5. Degree of 5. And we can continue to do that all the way down. Right? And what will we find? eventually, we're going to find what a cubic looks like, right? What a quadratic looks like, what linear looks like, what a constant looks like, right? Just a flat line. And then 0 is also a flat line, but it's just the x-axis, okay? And that's basically explaining what a derivative is, and in the same aspect, how to find the derivative, and in the same aspect, what your names of your polynomials are, what your degrees of the polynomials are, and the possible curves that are created by each polynomial. Okay? Which is absolutely crucial for what you're about to do today. Because if I were to give you this, and that I explained it, can you tell me what type of polynomial that is?
The kind you drew.
Quintic.
That's it.
CH4 humps.
Because there's 5 humps.
Because it's a 5th degree polynomial. Now you can't say whether it's a quintic with so many, like if it's a trinomial quintic or if it's a, right, but at least tell me it's a quintic. Okay?
Done.